Oh, hi everybody. So I'm just putting the final touches to a revamped cooling system on our computer here. I didn't do a video on it because it didn't seem like there was much interest in that kind of thing. But keep a lookout because this is going to be an important centerpiece in videos that are coming up, which will be interesting. Today, I wanted to talk about something different. Carburetors on engines are something that's actually quite unique and very versatile, and there's a lot of science, interesting science, that makes them work. So today, we're going to be servicing the carburetor off of my generator and talk about the science that actually makes them work. So hopefully it's enjoyable, and welcome to the Renaissance Builder. Okay, so carburetors, yes. Now, I'm going to be honest with you guys, this video actually kind of comes out of a necessity. My generator is not working. So I'm like, all right, well, let's start with, I know the carburetor has been sitting there for a long time, several years, and it turns out I left the gas valve on. So it sat there for several years with gasoline in it. And if there's one thing I can guarantee you, it's that if you leave a carburetor sit for an extended period of time with gasoline in it, you're going to need to service it. Because the gasoline, it varnishes. And what that means is that all the waxes and other chemicals in the gasoline, because it's not just hydrocarbons, they mix a bunch of crap in there with it, all those other chemicals can leave a coating of schmutz. I'm going to call it schmutz, but it's varnish on the internal parts. And if there's one thing carburetors are definitely good for, it's a bunch of tiny little orifices. And those tend to clog up very easily. So definitely, I know that the carburetor does need to be serviced. I'll be honest with you, I'm a little scared of something else. I noticed that the throttle plate is missing a screw. It may not be missing a screw, but I don't know, it scared me when I first saw it. Because that would mean the engine swallowed a screw, and well, I've been down that road before. Anyhow, before we get into this, I would absolutely love to talk about the science of what makes a carburetor actually work. And the reason I want to talk about it so much is because it's actually a very simple science, but it's huge in how much it affects everyday life that we go through. So it's kind of one of those things where it's a principle that when you understand it, you can look at everything else in life, everything else around you, and be like, oh yeah, so there's a science to why that works. I don't know, maybe it's just me, I'm a nerd, but I like it. So I'm going to share it. So carburetors, I'm going to go ahead and start taking this thing apart. We're going to use my handy dandy iFixit kit. I'm going to go ahead and take this thing apart while we talk about it because I don't want this to be a super lengthy video. Oh, look, bits are flying. So carburetors. The way that carburetors work in a nutshell, and I'm going to say layman's terms, is they use pressures to suck in a fluid and in turn atomize said fluid. Now, when I say pressures, what I'm really talking about is a venturi. A venturi is essentially an orifice, but it's think of a tube that gets skinny at a certain point. And where it gets skinny, then you inject a certain thing. In this case, it's fuel. The pressures, what happens to the pressures in that venturi is what makes a carburetor actually work. It really comes down to a principle called Bernoulli's principle. And Bernoulli is, you know, one of these old scientist dudes who just happened to figure all this stuff out. And of course, he put some math to it, like every scientist does. So taking the air cleaner off, now we're going to take the shroud off. And to do that, there's a plastic piece here. Is there a screw to hold that in place? Doesn't look like it. That looks like that just Snaps right down on. Yes, it does. So, oh, looks like there's some fuel in there that I just dripped on myself. Yay! Now it smells like gas. I have the fan on. I hope it's not too noisy. It's surely not noisier than the computer here, but I have the fan on because, well, I've got gasoline in here, and I don't need brain damage. I don't need any more brain damage. All right, so back on track. Bernoulli's principle. So Bernoulli is one of these old scientists, you know, Einstein, Newton kind of old scientists, Archimedes kind of thing, that he figured out that there is a pressure difference related to fluid velocity. Velocity being, you know, inertia or motion. Velocity is motion and vector. I think so. Anyhow, there's a certain Bernoulli figured out that there's a certain relationship between pressure and velocity, and he figured this all. He added some math to it, and then he figured out that it's predictable and all that kind of fun stuff. So, that being said, instead of me confusing you, I thought we're going to try something different. So we're going to cut over to the computer and we're going to Google this. Hopefully I don't get a copyright strike for something that we put on the screen, but we're going to Google this so that I can better describe what we're talking about. Now this is actually a very thorough a very thorough study guide on Bernoulli's principles from NASA of all places. But they got animations, and that's what I wanted. So this right here is essentially our carburetor. Now, what's happening here is we have air velocity comes across and moves this way, right? Well, when it meets this venturi section right here, remember a tube that gets smaller at a certain point. So when the air meets this here smaller section, it is forced to increase speed. Why is it forced to increase speed? Well, it's forced to increase speed because you have the same amount of volume behind it. Now, mind you, this builds a pressure back here because everything works on pressure. But as this air is incoming, this amount of air is forced to go through this space, which means we have to move more air through a smaller space, or the same air, the same mass through a smaller space, or more mass through the same space. However you want to look at it, it's going through a different, there's a difference there. So we need to move the same amount, so it has to speed up in order to accomplish that. It's the same way if you're filling a pool. You can either fill it for a short period of time with a large volume of water, or you can fill it with a garden hose and take forever. Same thing. However, what Bernoulli found out is when this happens, when the fluid speeds up, the pressure decreases. And there's a relationship between the pressure and the speed of the fluid and what the fluid's actually doing that allows the fluid to speed up. Or you could say that the speed allows the fluid, the speed allows the pressure to decrease. Either way, there's a very dynamic relationship between the speed of the fluid and the pressure that the fluid is under. So what he found is that when you speed the fluid up, the pressure decreases. So it actually forms a negative pressure relative to the other end of the venturi, the input side of the venturi. Now, why is this important in a carburetor, you might ask? Well, if I want to move fluid into that airspace, because the other thing it does is it creates turbulence. If I want to move a fluid into this airspace, if I want it to naturally suck, you can do the same thing with a straw. If I want to move fluid into this airspace, if I have more pressure on one side of the fluid than on the other, then the fluid will move. And that is what happens to a carburetor. Incidentally, that's also how airplanes fly. So we're going to get away. Hopefully we don't get copyright struck on any of this material. Hopefully we don't. It's on Google, so it should be, open space. I didn't download anything. This is all literally, you can see yourself. The site's right up here if you want to see it. So hopefully this doesn't copyright strike us, but hopefully that helps you understand it a little more. So that being said, let's go ahead and get into the actual carburetor itself. Sorry for the weird angle, but I really wanted to try and give you guys a good view of what we're actually working on, because I want you to understand, to take what we just read and researched, and actually apply it to what we're working on. And really the key science that I want you to remember is that a carburetor is pressure driven. It's pressure driven because the pressure outside of the bowl is greater than the pressure inside of the carburetor when there's air moving. And that's what drives the fuel into the carburetor. So it's pressure driven. And the reason I want to make that point is it actually refers to on a live stream when my brother asked, we don't always need to know why. You may not need to know why, but it may actually come in handy for you someday when you need to figure out why something moves. It's because of a pressure difference is why things move. Electricity works because of a potential difference between electrons on one side versus another. Pressure difference. Electrical pressure difference, otherwise known as electromotive force. Now, in the carburetor, it's the exact same thing. So let's go ahead and get into this, but practically speaking, a couple tips when you're taking apart a carburetor in case you want to service one for yourself. Be delicate with them, right? So you can buy carburetor repair kits, which come with all the gaskets and all the rubbers and things that you would need to rebuild the carburetor. But I'm going to be honest with you, I very rarely actually buy those kits. Oftentimes, you don't need to. Oftentimes, if you're careful enough, you can reuse the gaskets. For example, there's a gasket right here on this surface right here that that's hanging on by just a little bit. And it managed to stay in one piece when I broke it off, and I broke it off the engine carefully, but it managed to stay in one piece when I broke it off. Now what I'm going to do is, instead of trying to rip it off where it's stuck onto the metals, I'm actually going to use a razor blade, and I'm going to scrape it off ever so carefully, and voila, there's our gasket. I don't need to buy a new one. So being careful with these things can save you a lot of time and a lot of money. So at this point, I don't have any more gaskets than I need to be worried about on those surfaces, so I'm going to go ahead and take the bowl off. Now the bowl, in this case, is the item that actually holds the fuel as an interim for the carburetor to use. Ooh, she's tight. I might need a bigger screwdriver, and it's getting fuel everywhere. Those screws are way too tight. Somebody definitely boogered with this thing. I bought it used, by the way. I'm not that rich. So somebody definitely boogered with this thing beforehand. Alright, so now we take the bowl, and as I pointed out, the bowl is just that, a bowl. Now, what you want to look in here, practically speaking, as far as these things, is you want to see dirt and particles in there, and we don't have too much. Alright, so there's a gasket right around here that's actually a rubber O-ring, and I am going to take this off ever so carefully, because that I do need to preserve. Again, using the razor blade to ever so gently, and in this case, the entire plastic float bowl assembly comes up. Oh, I see. This gasket is more than just that little ring. Alright, so that's why we be careful about stuff, because this happens to have a whole pattern. So this is why you got to be careful with things if you don't want to buy the rebuild kit. Yeah, because you rip that and you're definitely going to need a new one. The important thing that you need to know about the float, the whole reason for the float is to control the amount of fuel that is in the float bowl, which is basically a reservoir that the carburetor can use to pull the fuel out of. Now, the float itself is actually a regulation device that allows the fuel tank it regulates the amount of fuel that it allows the fuel tank to put in. And it does that because you don't want the fuel tank over pressurizing the bowl. That would completely void any point of using the pressure difference across the carburetor. What you really want to pay attention to in this case, though, is there's a needle valve. I'm taking apart very carefully. Here it is. There's a little tiny needle valve that the float attaches to, and you got to be careful with that. It looks like this one has a rubber tip and it's in okay condition. There is a little bit of schmutz up in there, so we're going to go ahead and spray that down. There's also definitely some varnish and smudge in some of these other orifices that are used for pressure regulation, so that definitely needs to be cleaned out, and that's what we have the carburetor cleaner here to do. Now the other thing I'm seeing is the main venturi. Now the main venturi is right up the middle, and it basically applies to this standpipe right here. So while I'm holding the carburetor, there's a little brass standpipe that goes down into the middle of the float bowl assembly, and that standpipe connects, it feeds the fuel right into the middle, the venturi of the carburetor itself. Now I can see through this standpipe in order to confirm that it's not plugged up. However, there is an orifice down at the bottom, and this orifice down at the bottom of the standpipe is a regulation orifice. That is what determines how much fuel you want to allow into the engine or into the carburetor to control the air-fuel ratio of the engine. And that I can't even see through. So there's no way that was passing corrective volume of fuel. So that's definitely going to have to be cleaned as well. Yep. That hole indeed was designed to hold a screw. So that's very bad news for me. That means there's a very high possibility the engine swallowed a screw. Which means there's a very high possibility that that engine is complete garbage. Which means I paid way too much for a generator. That's not good. Well, anyhow, moving on to other parts of the carburetor that you might be interested in. So you have the float bowl, which acts as fuel regulation. So the float is there to ensure that the pressures across the carburetor stay consistent. A couple other devices we have in the carburetor that almost every carburetor has that you're going to deal with is one, the choke, and two, the throttle plate. Now the choke is there to try and enrich the mixture. If we block off the intake, because carburetors on engines are suction powered, not force, so the airflow is induced by a sucking action more than it is a blowing action. In other words, the piston goes down and the air has to go through it. Because of that, if we close the inlet of the carburetor, then it's going to force the engine as it's sucking on the carburetor. Because we blocked off the inlet, now it's going to suck significantly harder on the fuel itself and cause it to draw in a lot more fuel than it otherwise would. And the reason you would want to do that is if you need to, like for starting procedures, you may need to enrich the mixture to make sure there's enough there to actually burn. Now, the throttle plate is a bit different. The throttle plate itself actually cuts off the air suction to the carburetor. If we decrease the amount of air that's allowed to suck on the carburetor, then we also decrease the pressure inside the carburetor itself because we're limiting the amount of air through it. So by closing the front of it, we force more fuel in. By closing the back of it with a throttle plate, we actually cause the we slow down the airflow, which causes the carburetor to work less. So really, that's the majority of what you got to know about a carburetor. Bernoulli's principle. The act of speeding up a fluid causes the pressure to drop. And that's how carburetors work. And incidentally, planes fly. All right. So thank you very much, guys. I appreciate this. I'm going to go ahead and replace this mat because apparently it was not chemical proof. It is now ruined. Oh, that's messed up. So I ruined that, Matt. Okay. I'm going to go ahead and wash this thing down and put it back together and see if maybe I can't move on to what else might be wrong with this engine. Hopefully nothing. I really hope it's nothing. But let's find out. All right, so after putting this thing back together on the generator, checking to make sure the engine didn't actually swallow that screw we were referring to, as well as checking the oil, fixing the fuel line that was leaking, and cleaning out the fuel filter screen / shutoff valve contraption that it has, we're now ready to fire this thing up. And at that point is when I say, I love me's my Briggs & Strattons. So this mission has been very successful. So thank you everybody for watching. Really appreciate it. Hope you actually learned something and this didn't bore the bejesus out of you. It's a lot of stuff, and hopefully the edit isn't too bad either. But I thank you very much for watching. Make sure you hit that subscribe button and hit the bell icon so you know about the videos upcoming. This isn't going to be the last time we talk about engines and that kind of stuff, so if that's something that you're interested in, by all means, make sure the bell icon's clicked, because we'll be going over it some more. So thank you very much, everybody. As always, I'll see you in the next one.
Bye-bye.